Hey folks, how you doing today? Happy Tuesday. Turn this down a minute here. There we go. All right, hope you're doing well. We're moving on to chapter 4 here now, branching. We got branching this Tuesday and Thursday. Our code will start to get a little bit smarter now, a little bit more interesting. Can do a couple more things with it, and it'll start to be a lot more fun with the things that we can do. So I've got PyCharm opening here. Sorry, I forgot to open it a little bit sooner. And I'm going to start up a new project for chapter 4. Yes. Thank you for all the tips. Come on. Here we go. So it's going in the course repository folder here, and I'm going to put it in another folder here for chapter 4 called this branching. We should be off to the races. I'm going to do it in this window. I can close all the chapter 3 stuff. We don't need to keep that around. No big deal. All right. So the idea here with branching is that we're now going to let our code make decisions. So our code can decide whether or not it should do something, which is really cool. So previously, the only thing we could do was it would do the first line, do the second line, do the third line, do the fourth line, on and on and on, from top to bottom, which, you know, could be interesting and could be powerful. We could still get some user input and take some actions based on it, or do some arithmetic based on their numbers, but there wasn't a whole lot of like choices that we can make or decisions that we can make based on what they entered. So one of the things that we can do, let's take a look and see, hey, if a number is negative, let's make it positive. Let's figure out how to do our own absolute value function. So we'll ask the user, so we'll print enter a number, and then we'll have, I don't know, the number is an int of the input, not an input. Oh, we can actually put this right inside. Sorry, keep forgetting. I'll just put it right inside the input here. Enter a number. We don't have to print it first. We've got a number. Now, again, we assume most people probably don't enter numbers of decimal places, so I'm not concerned about this being a float versus an int, but it will work either way. So what we do is we're going to say if. So if is the keyword. You notice it shows up here in nice orange. That's a reserved Python word here. I'm going to say if, and now what I have to do is I have to give it an expression. Now, if you say if, the only two answers can be true or false. Right? It's a Boolean expression that has to go in here as our technical term for it. Something that will either give me a true or a false. There's no maybes. There's no 0.5s. It's either yes, no, true, false, right? 1, 0. Essentially, we're saying, hey, if this is true, then I want to do something. Right? That's what goes in the if block here. So we're going to say, hey, if number, and now we get to use all of our relational operators. Now that's our term for them. You're familiar with the relational operators, like less than. Right, or equals to. Now, the problem with a single equal sign is that's our assignment operator. So if I want to check if it equals something, I actually use double equal sign. Say if number equals something. I could say if number does not equal something, that's exclamation mark equals here. But we want to go with less than. So we're going to say if number is less than 0. Right, that's our less than. We could do less than or equal to, but 0 is fine. It's allowed to be 0. So we just want if it's less than 0. Now, our syntax for this is I put a colon. So we say if, and this is our Boolean expression, this will either be true or false, right? The number is less than 0 or it's not. Yes or no. And if it is less than 0, then everything that is tabbed underneath this if here is going to run. So we put the colon, and all the code that we want to run if this is true needs to happen tabbed inside of this if number less than 0 colon. So this is super important in Python. The tabbing has meanings here. So we're going to say, okay, if number is less than 0, well, how do I make number positive then? Well, I can take number, right, times equals -1, right, multiply by -1. That should turn it back into a positive number. Because if it's negative, a negative times a negative gives me a positive. And then we can print out number. Sure. Not very interesting, right? But let's give it a try. Now, you'll notice there's no, if this was false, nothing happens here. So if it's not less than 0, this code does not run. So this will only run if this is true, then that block of code runs. So if I enter number 42, I just get out 42. Right? No change happens here. But if I enter -7, I'm going to get out +7 because that is less than 0. It's true. This line of code will run. And we could even print, hey, that is a negative number. We make it positive for you. I don't know, we'll just have some fun. Let's try it again. And this way we're going to see, hey, another print is going to happen if it's negative. So if we enter like -2, we say, hey, that's negative, let me make it positive. But now we'll see if I give it a positive number, that line of code doesn't run. Okay. Maybe, you know, colons and spaces just to make that look a little prettier here. Sure. So we're allowed to now make our program make decisions. This is branching, right? So if this is true, this line of code will run. So now at this point, we don't necessarily run every line of code in our program. Right? It is only going to run if this is true here. And we can do all sorts of expressions, right? So we get all sorts of them. So you get the less thans, you get the less than or equal to, you get the greater than, you get the greater than or equal to. Now, the double equals, right, is the equal sign, not greater. Thank you, spell check. And then a exclamation mark equal sign is not equals. So I could ask them to guess a number, right? So let's say guess is an int of an input of guess a number 1 to 100. And again, you know, colon and space, make that look a little pretty. Now we can check, hey, if guess does not, if guess does not equal 42, colon. Now PyCharm's automatically going to tab it for you so that everything is going to belong to this if block, if this is true. We can print not it, or that's not the number. Number I was thinking of. Try again. Sure, we could do that, right? And then really we can just copy paste this code a couple times. Now, it's not going to go back to this left alignment here. It's going to keep on tabbing until you tell it to go back one. So just be careful. If you're going to paste something in, make sure you don't paste it in while it's indented, because you don't want that, right? We want to ask them again. Hey, Crow, how you doing today? Or maybe we do want it. So if we wanted to, we could prompt them only to guess again if they were wrong, which might make sense, right? Maybe we just put that, maybe we do want it tabbed in. So try again, have them guess a number. That way, if it is not 42. Yeah, no problem, Bay. So part 2 of lab 2. Yeah, we can go back. No big deal here. We've grabbed that here. So that's all about using the string index notation. So with part 2 of our lab, we said, hey, give me an 8-character string, because I need to know how many letters are in it, and then we're going to take individual characters out of that string. So if I give you a string, here, maybe we'll do this, start at the top, you know, some word, right, is an input of enter an 8-character word, please. Okay, so some word, index of, with these square brace notations, right? What's the index of the first character? So we're going to make an encoded word, right? This will be our encoded word. We're going to build it out taking, we want the first character, the third character, the fifth character, and the seventh character, right? We want to skip every other. And then we want to come back and we want to take the second character, the fourth character, the sixth character, and the eighth character. So using this index notation of a string, what's the first character in a string? It's just like the index notation when we work with a list. Yeah, 0. Thanks, Crow. So 0 will be the first character. And then I can append, right, do that string concatenation thing here. What's the third character in a string? What's its index? 2. Yep. And then keep on going. And the next one, and the next one. So what's the fifth character? 4, yep, and then the seventh character. I think you guys get the pattern here, right? And then I can take my encoded word. I'm just running out of space here, so I'm going to do this plus equals and just keep adding more, right? So now now that we did the first, third, fifth, and seventh, how do we get the second, 4th, 6th, and 8th character. And what's the index of the second character? This gets the 1st, 3rd, 5th, and 7th character. Yeah, all the odds, right? Yep. So 1, 3, 5, and 7, because our indexes are 1 less than their position. So the first item is at index 0. Right? So we're always 1 less than. And then this adds the 2nd, 4th, 6th, and 8th character. And then we just print out that encoded word. Right, so if your word was dinosaur, right, we should get, what did I say here? DINS-U-I-O-R for dinosaur. Dinosaur. DINS-U-I-O-R. Right, that's all it is. So it's just practice here using this index notation on strings. That was lab 2, part 2. Nothing super exciting, just some practice, right? We got to get familiar with this notation. Does that make sense, Bay? Yeah, of course. All right, so back to our guessing game here. So if it is not 42, which sounds a little bit confusing, but we're saying if it is 42, if it's not 42, do this. So if it is 42, none of this runs, which we probably don't want to ask them again if they already guessed 42, which I think makes sense. So we can put this right inside. We'll say, guess again. And if it's not, we'll have them guess again. So it's like 3 different guesses to guess a number, right? So the first one, if it's not 42, says that's wrong, guess again. If it's still not 42, wrong, guess again. If it's still not 42, that's not the number I was thinking of. Try again. Or maybe we just tell them, it's still wrong, thinking of the number 42. Okay, so again, this is kind of a difficult guessing game here. So sure, we'll just stop and run. I think I told it run. Did I tell it run? Yeah, stop and rerun. There we go. So 8 character letter, sure, ASDF, ASDF. All right, enter a number, sure, this one doesn't matter. All right, now guess a number. So if we guess 10, it's not 42. If we guess 100, it's not 42. If we guess 42, nothing happens, right? We don't, if it is, that's it. But if it's not 42, then this happens. So it'd be nice, though, if we could say, okay, if this is true, do something. If it's not true, we'll do something else. What's 2 to the 7th, Crow? I should remember that. That's 128, isn't it? 2 to the 7th? 2 to the 7th power? Yeah, 128. We should be able to guess it in 7 guesses. Or less. Yep, because you always split the difference. So what that lets us do now, we can say, okay, well, if they didn't guess it right, what we're going to do, and now this gets a little bit tricky with all this nesting here, is we're going to come down to the same indentation level as the if. And we can say else. So the else will run if the if does not. So if it's true, this runs. If it's not true, this one runs. Ooh, log 2 of 100. That's some fancy math there, Pro. I got a couple math majors in the class. They might be better doing that log notation than I would. All right, so if this is true, this one runs. If it's not true, we print, you guessed it. Now we could also, we would need other else's here. So there's a slight light line here underneath this if, so that you can kind of see where the indentation is. I'll have an else here, again for you guessed it. And then one last one here, else for, you guessed it, for that very first if. So if on our very first guess, we guess that it's 42. It is not 42, so the if doesn't run, right? So then this else will run here. So you see they're attached based on alignment here. So it gets a little bit tricky with this nested if-else sort of thing here, but it works. It works. Okay, so let's give it a try. So now at any point in time, if I guess 42, I should get, you guessed it right. So 42, you guessed it. Great. We got the right message. Now, that's not all that helpful, though. Wouldn't it be nice if we had an option to tell them, hey, it's too high or too low? Well, we can add that in. So if it's not 42, we'll tell them it's not 42. I have no idea what that says, need original name. So we can check if it's not 42, well, it's then either going to be too high or too low. Right? We can do that. So instead of this just being an else here, we can say elif. So elif is short for else if. The wonderful people who wrote Python decided typing else if was too many letters, so we have elif. Sure, so elif colon, elif. Okay, now what are we going to check if this is true? So if it's not equals, let's check if guess is less than 42. We'll print too low. Now the problem is all of this nesting stuff is going to get really messy here. So let me take this out for now. I'm going to just cut all that out. So we'll say, okay, if it's not 42, oh, well, okay, well, that's not actually what I want here. Because not 42 is going to be true before less than 42 is true. So this is no good. So we can say if it is 42, we can say, you guessed it right. Yay. If this is not true, then we'll go to the next else if and compare. Okay, is it less than 42? If it's less than 42, we'll print too low. Now, if it's not equal to and it's not less than, we know it has to be greater than. So you know, let's flip this. Let's say if it's greater than, we'll say too high. Why not? Else if it's not greater than, if it's too low, else you guessed it. So if it's not too high, it's not too low, you must have guessed it here. So this is a chain of if, else if, and you can have as many of these conditions as you want in here. Else if, else if, else if, else if. You can have 100 if you want to go crazy. No big deal. Right? Sure. One and only one of these will run, right? If this is true, none of this gets looked at in Python. If this one is true, none of the rest gets looked at in Python. If this isn't true and this isn't true, my else will run. Sort of, we might call that the default case here. So, great. We need to guess the number here. But now, if I want them to guess again, I don't want to have to do it inside of the too high and inside of the too low. I don't want to have to do that. That's no fun. Right? That's going to be a little bit messy. So I can say, hey, how about if guess does not equal 42? Let's go back to what we were doing before. Let's ask them to guess again. We can say, guess again, right? Guess a number between 1 and 100. Too high, too low, or we guessed it. Right? And then we can repeat. So if they did guess 42, the next time we check down here, not 42 will be false because it is 42, and this won't run, so we won't ask them to guess again. So now we can kind of quickly have them guess it here, right? And then we don't have to mess with all that crazy indentation. Oops, oh, bummer. If you don't have a long enough string, this one crashes with that index error. Didn't type ASDF twice. There we go. First number doesn't matter. All right, guess a number. So what number should we pick then? We want to do too high or too low, or right at 42. Any one of them should work for us. What do you folks want to try first? You tell me. 1. All right, let's try 1. So 1 should be too low. So it says too low, guess again. Okay, so it was not greater than, it was less than, so we printed too low. And then our guess was not 42, so we said guess again. Now we need to guess. All right, 51. 51 is too high. So guess was greater, it says too high. It's still not 42, so let's ask them to guess again. This is our last guess. Did we guess it right? 42? You guessed it. Hooray! $26. Yeah, I'm going to get too low again. So we can use these if, else if chains here to make something run. So this one's not necessarily the most interesting example. Let's do one that you might be more familiar with here. Let's ask for a score. I'll say we want an int of an input. A score. Oops, that should be in quotes, sorry. Let's score 1 to 100, or I guess 0 is a valid score, right? 0 to 100. Now we can check. I want to see, okay, I'm going to take your score number, I'm going to translate it to a letter for you. So if score is greater than or equal to 94, 94, right? We're going to print A. If it's not greater than or equal to 94, I can say elif, if score is greater than or equal to 90, print A minus. If it's not greater than or equal to 94, and it's not greater than or equal to 90, elif, if score is greater than or equal to 87, we'll print that's a B plus. If it's not greater than or equal to 87, let's check if it's greater than or equal to 84. We'll print a B. If it's not greater than or equal to 84, elif score is greater than or equal to 80, we'll print B minus. Elif, if the score is not greater than or equal to 80, let's check if it's greater than or equal to 77. That's a C plus. Elif. Now again, you gotta be careful with all the tabbing here. All of these in the chain need to be aligned. If my score is greater than or equal to 74, let's print a C. If it's not a C, elif score is greater than or equal to 70, print a C minus. If it's not a C minus, if score is greater than or equal to 67, print D plus. And I think that stops, right? Let's check. Oh, I don't need Firefox open. Did it actually open? I don't know. Let's go back and take a look at our grading scale here. Yeah, we don't need Firefox. Go away, Firefox. I should switch everything over to Firefox. I think it does perform better. Close. There we go. No, come back. Come back. Oh my goodness. Let's see. Okay, we go down to D and D minus. Okay, sure. So if it's not greater than or equal to 67, if score is greater than or equal to 64, we'll print a D. Else if the score is greater than or equal to 60, we'll print a D minus. And if it's not any of those, else, we're going to print an F. Right? So that you can have this ending else, this default case, if you want. So if you didn't get any of these other letters, right, it's got to be an F. Because it wasn't greater than or equal to 94, and on down and on down and on down. So we can see, depending on what the score is, we'll get a different letter. So because they're in this chain of if, else if, else if, else if, elif, 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 else, one and only one of these will run. We call this mutually exclusive. One and only one will run. Exclusive. I think I spelled that. Okay, yeah, spell check was fine. So it's a chain. So as soon as one of them runs, right, if this if is true, it never checks the rest of them. Because the if block ran, this is essentially an else block. So you could write it like if score is greater than or equal to 94, 90, what? Yeah, 94, it's an A. Print A. Else, if score is greater than or equal to 90, print A minus. So why this is nice is you don't have to have this other level of indentation. Otherwise it's else, and then this has to be inside of that else tabbed in one. The elif lets us say, oh, I'm going to put them all on the same line. So it's just a nicer format here than doing it this way. It's nicer looking, the nested version. Right, I'm just going to leave that all commented out. We don't actually want any of that to run. Okay. How you folks doing so far? Hanging in there with this if, else if stuff? Okay, awesome. Check in here, making sure we're following along with the chapter. Yep, we did equals, we did not equals, we did greater than, we did less than, we did else's, elifs. Cool. Yeah, that's the problem, Beyond. I mean, Beyumd? Can I just call you Bay? Otherwise I can try and figure it out. And that's why we practice. That's why we have labs every week. It's definitely going to take practice. The Zybooks will make you practice. I'm a firm believer that the only thing that makes you a better coder is writing code. And I should say, not just writing any code, but like writing working code, if you want to clarify that. So, you know, the more practice, the better. And that's how you get familiar with things. There's that rule of 10,000 hours for mastery. It takes you about 10,000 hours of doing something before you can master that particular subject. And that's a lot of time, right? 10,000 hours. If you imagine a full-time job is 40 hours, right? Times 50 hours, 50 weeks in a year, that's only 2,000 hours. That's for 5 years working at something completely full-time to obtain mastery of it. And that's assuming that you're actually putting all of your working hours into that subject and not getting distracted and doing other, nonsensical administrative tasks or meetings and whatever other things. So at least 5 years of working on something full-time to gain mastery of it. Okay, so our relational operators, let me put this in here. These are relational operators. To determine if we relate with something. Now, there's a lot of good practice in here. Let's see. So the other kind of operator we can use is called a logical operator. Now, relational operators deal with, right, is this thing, how does it relate to this thing? A logical operator lets us combine or operate on logic or true-false statements. So if you go to McDonald's and they say, do you want a burger and fries? Of course you're going to say, no, your fries are disgusting. I don't want a burger and fries. Because McDonald's fries are awful, right? If you say and, you're saying, do you want both of these things? Right? So we can say, with the and operator, true and true will equal true. But true and false will be false. If you detest McDonald's fries because they're just gross and overfried and too salty and whatever, if they say, do you want a burger and fries, you're going to say no, because you don't want both things. So the and operator, so this is a logical operator, here with and, is going to combine two true or falses, and you're going to get just a single true or false result. On the other case, if you don't like burgers, but you do like the fries for whatever reason, it's also false. And if they're both false, if you hate their burgers and their fries, you'll go false. Maybe you're only there for breakfast. I don't know. So both things have to be true when you're anding for the result to be true, right? But there's also the or operator, right? You say, hey, do you want a burger or fries? If you want either of those things, the whole thing is true, right? If you want a burger or fries, if you want the burger, but you don't want the fries, you still say yes, right? Do you want this or this? Yes. But then you're going to specify, yeah, I only want that one. But if someone asks you, burger or fries, you say yes. If it's false or true, again, the whole thing is true. Because if either side of an or is true, or both sides, the whole thing's true. Now, the only time a or is false is if both sides are false. So do you want a burger or fries? If you don't like their burgers and you don't like their fries, the whole thing is false. That's false and false will be false. There's also a not operator, which is pretty self-explanatory. Not true is false, and not false is true. Right? Not will just flip whatever it is here. And we can use these in all sorts of combinations here. So I can, instead of doing that chain of if, else, if, else, if, else, ifs, I can say if score is greater than or equal to, let's do 90, and score is less than 94. Right, I can take, okay, if this is true and this is true, that's the A- range. Okay, now Python is actually good at these sort of range calculations. So we could also say here, if 90 is less than or equal to score is less than 94. Right, and this is how you might be used to writing in a math class. Right, print A-, like this sort of valid range, yeah, this is fine in math. Other programming languages, you have to do this and logic. You can't always say, put two different relational operators in a single expression. So 2 Relationals in a single expression works in Python, not so many other languages. Definitely C++ is not, this just doesn't work in C++. So, sure, I mean, they will do the exact same thing, right? They both have to be true. You have to be less than 94 and greater than or equal to 90 for this one to run. So it's essentially the anding here, but it's a little easier to read, right? We're saying scores greater than or equal to 90 and less than 94. Yeah, scores greater than or equal to 90 and less than 94. Right? Or 90 is less than or equal to score. I mean, you can read those relationals either direction. And Python doesn't care, right? So when we said, hey, was score less than 94? Again, this is the usual way to run it here. You can, where should I put that? We could say if 94 is greater than or less than or equal to score, print A. This is typically frowned upon for a single one. So if you are only checking single value, the variable should go first. It's just kind of an awkward way to read this. Is 94 less than or equal to score? Variable, right? Versus if score is greater than or equal to 94, print A, right? So this is just an easier way to read it. They both do the exact same thing, right? And you can read those relational operators either direction. But this is frowned upon. This is the right. It just comes off the tongue a little easier, and as you're reading through it, remember the code's here for people. Python could care less how we do it. As long as it gets valid syntax, Python's happy. The code here is for people to read, for you to read, for me to read, and eventually your coworkers to read. To relationals, yep. So this is fine in Python, other languages not so much. Okay. So we can combine these sorts of operations here, or I could ask for two different numbers, right? I could say, okay, enter x equals an int of an input. Please enter a value for x, and y is an int of an input. Please enter a value for y. And then we can check, hey, let's see, is it quadrant 1, quadrant 2, quadrant 3, or quadrant 4? So we can say if x is greater than or equal to 0, I think we're still in quadrant 1 at 0, right? I think 0, 0 counts as quadrant 1. I don't know, math major folks tell me if I'm wrong here. We'll say if x is greater than or equal to 0 and y is greater than or equal to 0. We'll print you are in quad 1. Elif. Okay, if that's not true, right? If both of these aren't true, now what are we going to check? Let's say, okay, is x greater than or equal to 0 and y is less than 0. Right? PyCharm is going to try and help simplify. We don't need to simplify right now. I mean, technically we could. So if this is not true, right, we're never going to get here. It's fine. This is fine. So let's say, okay, we're greater than or equal to 0 for x, but y is negative. That puts us in quad 4, right? We'll print you are in quad 4. If that's not true, all right, let's see if they're both negative. If x is less than 0 and y is less than 0, print we're in quad 3. So maybe we should have done those in order. I'm sorry, I'm feeling a little bad now. So we'll say elif. So if x is negative, less than 0, and y is positive, print you are in quad 2, right? And then I'll move this one down 1. So if x is negative and y is positive, we're in quad 2. If they're both negative, that's quad 3. And if y is negative and x is positive, that's quad 4. Now, we probably don't need this last if here, because if you're not in quad 1, 2, or 3, you've got to be in 4, right? So I'm actually going to comment that one out. I'm just going to say else, right? You aren't in 1, 2, 3. You, by default, be in 4. Right? There's nothing wrong with adding it here, but it's extra typing that we didn't need to do. Right? So just an else is fine here. So this logical operators here, we can AND these things together. Both of these must be true for this to be true. All right, let's see. Ranges, great. Sure, more ranges, more logical operators. This is going to take some practice for sure. And Zybooks does a good job of making you do lots and lots and lots of practice, which is good. I think that's pretty good. All right. Nested statements, sure. Okay, so when we compare strings, strings are a little tricky here. So let's ask them for their name. Say name as an input. Enter your name. Now if I want to say if name equals Eric, this will work, right? We'll print, hi, that's my name too. Else maybe we'll print name, nice to meet you. I'm Eric. Oops, I'm Eric. Again, sure, it's the computer talking here. But so if your name matches Eric, I'll print, hey, that's my name too. Otherwise, right, that else, if it's not Eric, something else, hey, it's nice to meet you. Now, the tricky part with strings is that Python is case sensitive. So if we get down here, and let's give it a shot real quick. 142, great. 1 score, all right, value for x, 1 and 1. Puts us in quad 1. All right, name. So if I do Eric all lowercase, I don't know if you, there we go. If I zoom that in a little bit, you can see. Eric all lowercase. Do I have an extra input? Where do I have an extra input? That's weird. Like, name. Huh, it waited for like an extra enter key. I'm a little confused, but that's okay. So it says, oh, Eric, nice to meet you, because capital E is not the same as lowercase e. So case-sensitive matching when we're dealing with strings is a little bit tricky. Let's run this one more time. I'll try the capital E Eric. Let's see if we can get that to work. 111. Okay, enter your name. Capital E Eric. And I get, hey, that's my name too. All right, I don't know what was going on last time. I got like that extra enter key, but that's fine. So if it matches, letter for letter, case for case, right? So Python is case sensitive in comparing strings. You gotta be a little bit careful here. But you can say equals, you can say not equals. Now what's fun too is you can compare lists, right? So we'll ask for a list of numbers. So we're gonna have my numbers equals a list, and we'll ask them to enter some numbers, right? So we'll take my numbers, and we're gonna append in here an int of an input, I always do that all the time. Enter a number. And we'll do that 3 times, right? We'll just ask for 3 numbers. 1, 2, 3. And we can check if, and then we'll have, I don't know, the winning numbers or something, right? Winning numbers equals a list of, how about we do 3, 2, 1. Now let's check, let's see if they match. So if my numbers equals the winning numbers, print, you win the daily 3 lotto. If you didn't win, else print, you lost. Thanks for donating your money. Okay, let's give it a shot. Let's see if we can get some winning numbers here. Oh, ASDF twice. Sorry. Maybe I should put all the new stuff at the top so I don't have to run through this every time. All right, enter a number. So we'll do 1, 2, and 3. And we lost. Uh-oh. Bummer. Let's try again. So, right, they don't match. We shouldn't get an equals. Let's try it again. All right, here we go. Enter a number. Let's try 3, 2, and 1. And we win the daily 3 lotto. So when you compare a list with another list, right, it's first item, second item, third item in each list, one by one by one. So they can match, right? If they're checking one item at a time, one item by one item by one item. Now, is a list greater than or less than?
It's going to check, hey, is the first item greater than or less than? If they're equal, we're going to check the next one. If they're equal, we're going to check the next one. If they're equal, we're going to check the next one and work our way down. Typically, that's not all that useful, right? To say, hey, is this list bigger than this list? Not really what we want to like compare the items inside of it. That gets to be a little bit silly. And for dictionaries, if they have the same keys, they'll be equal. It doesn't matter what the associated values are. It only compares keys. But again, most of the time you don't want to say, hey, is this collection of items equal to this collection of items? That's not going to be quite as interesting or useful as we want to do. Now, we get another operator, which is super handy here. We're going to look at, let me make sure, yeah, we're not getting too far. And this is probably the last thing we cover today. And we got a little bit more coming up after. So, like in our first lab, we had that menu of items we were going to sell. Here's our dictionary. We sold coffee for, $1.25. And then we sold espresso. Espresso's always cost more for some reason, like $2 per shot. Sure. And then we asked, what do you want to buy? So the, item to buy was an input of what do you want to buy? And if I just printed out the item to buy, item to buy costs, and then go to the menu dictionary, look up the key of the item to buy here. This works great if I tell it coffee or espresso. I'll leave it at the bottom. It's all right. We can just hit one a bunch of times here. Okay, so what do you want to buy? So if we type coffee, it works. Coffee costs $1.25. If I give you something that's not in that dictionary, though, we're going to crash. So if I say coffee, even with a lowercase c, right, because it's case sensitive, it crashes here with a key error. That's no good. You don't want your programs to crash. So what we can do is we can use this new operator. Remember I said, hey, coffee's not in that list. Coffee's not in that dictionary. The operator is in. We can say if the item to buy is in the menu. Right? Hey, is it in there? Great. Let's take a look. If it's in there, great. Otherwise, we'll say else print we don't sell that. Let's give it a shot. Bunch of ones. There we go. What do you want to buy? Coffee, lowercase c. We don't sell that. Right? So with dictionaries, in checks for a key. In will work with lists. In will work with sets. In will work with tuples, however you want to call them. So in is very powerful. It'll check to see if it's in the collection, but when it comes to dictionaries, it's only checking the keys, not the values. Not the associated value. So like if you want to say, hey, what's on your dollar menu? I can't check for things that where the cost is $1. That's not going to work for us. Right, so the in operator is really handy here for checking, is it in a collection? And we'll end it at middle of 4.9. All right, awesome. So we are working our way through chapter 4 here. We got a little bit more to work on. I don't want to go too far today. There's a couple other things we need to look at that are very important. And I think we're doing pretty good getting through it. Don't forget the project is coming up. Let's take a peek here. Make sure I remember what the due date is. So our first project due October 7th. I know that seems like a little far way off, but again, start early. So to do Thursday before class starts, a week from Thursday, not this Thursday, but a week from Thursday. Get started early on it. So if you get stuck somewhere, I can help get you unstuck. If you're stuck and it's October 6th at night or early in the morning on October 7th and you're stuck, I'm going to have limited availability to help you. Right? There's one of me and I think 18 of you folks now. I think we're down to 18 maybe, or 17. I'd have to double check. So start early, get working on it. And, again, if you get stuck somewhere, give it a good, half hour of trying to figure it out yourself and then reach out. Call, text, email, find me on Discord. I'm happy to hop on a screen share and figure out what's got you stuck here to get you moving in the right direction. The goal is everyone gets 100%. Right? I would be super happy if everyone got 100% on it. That's fantastic. So, right, this basic retirement calculator, calculate instead of calculator. Maybe that's autocorrect. We're just doing some arithmetic here, just practicing some of this arithmetic here as we're going, okay? So get started on that one. Again, make sure you're in the Project 1 repository for that. Each lab will have a repository, each project will have a repository, and we can go from there. And don't forget the Chapter 3 quiz is also coming up due next Thursday, 11:59 p.m. So I think I'm mostly up to date. I got to finish grading a couple more Lab 2s, but things are going relatively well for you folks. Let me know what I can do for you. And if not, we'll call it a day a little bit early. Go get working on the iBooks, right? Get some of that practice in, and we can go from there. All right, should we see if anyone's around in Twitch land for us to raid for fun? We can see who's around. So this is Chapter 4, Bandawi, in the iBook. So ideally, you're doing the iBook right as we're covering it in class. Yeah, let's see. Is anybody around? Yeah, I'm going to put on the ending screen here real quick. This makes everything load a little faster if I'm not doing my screen share. Yep, great. Appreciate you double checking. Let's see. Who's around and streaming? Oh, nobody else is online? Nobody else is streaming, really? And no one else in the Knowledge Fellowship is streaming. Oh, we could do rocketology. That's always fun. Let's learn about some rockets here. Hopefully I can spell that right. All right, folks. Again, just for fun, head on over there and say hi. Learn something about rockets. And I'll see you folks on Thursday, unless you talk to me before then. Take care.